So let's continue our discussion of the compound pendulum example. So here we have a problem. A uniform ring of radius capital R is suspended from a nail vertically. The ring is okay. So the ring is made to execute oscillations in a vertical plane. Find the period. So that's a question here. So let's try to visualize the problem. So let's quite say simple one. So you consider there is a nail hammered onto the wall, and we have got a ring, okay, of certain radius r. So this is the ring. So let's assume that the ring is hanging from the nail like this, okay. Of course, so you should pass through this one, okay. Now let's say that r is the radius and let m be the mass of the ring. So as far as this is a rigid body able to oscillate about the pivot point O, we can consider this as a compound pendulum, okay, theoretically. So you know the time period for the compound pendulum t is equal to, you can just work it out yourself, but I'm just doing it, okay, right forward. So 2 pi, just now we have, okay, completed 2 pi root of k square plus l square. That's the general equation that we are at, divided by what? GL. So this is a common equation. Now you can find out the time period if you know the radius of gyration, okay, radius of gyration of this object. So you know this is the O here. So let me say that this is a center, this is a center, C or something like that. You know for this ring, uniform ring, the center of gravity will be lying at the center, okay, geometrical center, so G. So for this particular object, you know, okay, this will be the center of mass axis, this will be center of mass axis. So the distance from the rim to here means this is the point of suspension. Actually, you know it to be the rim. So this distance will be L, okay, that is length of the pendulum. So L will be equal to R in this example, right? L equal to R this example. So let's say for the ring, you know, I about the center of mass, that will be equal to you know, the standard result is mr square, that is equal to mr square, okay, that will be equal to mk square. That is why, okay, it can be equated with the standard equation in terms of the radius of gyration. So of course this is also, I may say that both are em. So this em and m will get cancelled. So you can see that it will give you the idea r square is equal to k square, r square equal to k square for the ring, okay. So and also you can see that L equal to R. So L equal to R and R square equal to K square. So I can say this equation number 1. So equation number 1 will be reducing to T equal to 2 pi into root of K square, means that is R square, and L is also what? R. So it will be also R square divided by G into L is R. So it will be 2R square by GR. So it will be equal to T equal to 2 pi into root of 2R square by that one. So it will be 2R by G, right? And what is this 2R? So that is the answer here. So 2R is nothing but the diameter, okay. So 2 pi into root of diameter by G, that will be the answer for this particular problem, okay. So it's now if here it is given as a ring, if it is a disc, right? If in place of a ring it were a disc, for a disc, what will be this answer? For a disc of radius r and mass m, the only difference is that, okay, in the case of disc also equal to, you know, the length of the compound pendulum, that will be equal to the radius, right? Okay, so the same reason. So this is a disc, okay, right, means the mass is distributed throughout, and it is pivot here at the rim. So the center of mass will be here, G. So the distance from the pivot point O to the center of mass will be, that is what we have naming as L, the length of the compound pendulum. So L equal to once again R, right? But for the radius of gyration, you know, radius of gyration, I about the center of mass for the disc we have learned, that is equal to mr square by 2, mr square by 2, which we have to equate with the mk square. So m and m will be getting cancelled. So we will be getting k square is equal to r square by 2. Earlier k square was equal to r square in the case of a ring, but k square will be equal to r square by 2 in the case of a disc. So I am using that result here. k square is equal to r square by 2. So substituting in the same equation number 1, so what will be equation number 1 giving you? So it will be giving you t equal to pi into root of what will be that one, see, r square plus, right, what will be like that? So k square is r square by 2 plus what, l equal to r, so it will be r square divided by g into l is r, okay, so gr. So what will happen is that it is equal to, see, it will be 2r square plus 3r square by 2, so it will be 2 pi into root of, okay, 3r square divided by 2gr, that will be, so r and r will be getting answers. So finally you are left out with 2 pi into root of 3 by 2r or 3r by 2g, okay, 3 by 2r is 1.5r, right? So length of the equivalent simple pendulum will be equal to 1.5r here. Length of the equivalent simple pendulum will be equal to okay, it's not 1.5r here, length of the equivalent simple pendulum. And here in this example, the length of the equivalent simple pendulum will be capital L, I am writing, that is equal to 2r. In the case of ring, length of the equivalent simple pendulum, you know what actually it is that. So you can compare this equation with the simple pendulum equation, 2 pi root of some L by G. So which quantity comes in place of the L? You can see here it is 2r, but here it is what? 3 by 2r. 3 by 2r is 1.5r. So that way also the question can be asked, what is the length of the equivalent pendulum in the case of this one? Okay. So this is this can be done directly from your knowledge of Newtonian mechanics, but I just told it associated with the Lagrangian method. That's all. Okay. So that's about the compound pendulum and the related questions that you can get it. Now there is another variety of compound pendulum that is known as physical pendulum. So there are several pendula that is used. So the physical pendulum. So what is meant by physical pendulum? A physical pendulum is a sphere. Okay, so it's a special case. A sphere of mass m, and radius r, sphere of mass m and radius r, suspended at the end of a light string. Okay, suspended by a string. So that is what is known as a physical pendulum. So if you show it diagrammatically, I can show that if this is the pivot point and you have got some string of length L, and at the end of the string you have got a sphere of some dimensions. So the radius r, okay, and mass m. So up to the center of mass, you know, this is G, center of mass, the length is n. So this sphere has got some finite size, then that is known as a physical pendulum. And if the size of this particular bob, what you call spherical pendulum, is small, if it is point mass, then it is known as a simple pendulum. So I can say physical pendulum is a special case of what? A compound pendulum, and the simple pendulum is a very special case of what? Physical pendulum. Okay, so that is the way in which you can understand. So what will be the see time period in this case? The time period in this case, you know, the time period for any compound pendulum is given by the general equation that you have derived just now. So that is what? 2 pi into root of k square plus L square divided by GL. So that is the equation for what? The compound pendulum, any dimension. So in our case, only what you have to do is that you have to find out the k value, right? You have to find out the k value here. So you can see that the k value, how to find out the k value? So this is the, okay, you know, like, so let's find out the value of k here. See, I about the center of mass, that will be equal to, you know, for a sphere, I about the center of mass is equal to 2 by 5 mr square, right? I think that will be the method. 2 by 5 mr square, if my memory is correct, so that we can just compare with it, that is equal to mk square. So you can just cancel out m and m, you can cancel out, so you'll be getting k square is equal to simply 2 by 5 mr square, that is no, okay, sorry, m is called 2 by 5 r square, right? So k square will be 2 by 5 r square. So here you can just substitute 2 pi into root of k square is 2 by 5 r square plus what? L square. So L square I have to retain as L square itself, So divided by GL, right? GL. So that is the equation for simple physical pendulum. Now, for a point mass bulb, if the bulb is point mass, you can just take R is approximately tending to 0. So what will be that equation now becoming? So this equation X will become, so T is equal to simply 2 pi into root of what? So when R is equal to 0, this term will be gone. So it will be what? L and L square by GL. So L and 1 L here get cancelled. So it will be 2 pi root of L by G. So you can see that this equation reduces to that of what? The simple pendulum. So that's one reason I told you that a physical pendulum can be regarded as a special case of what? A compound pendulum, where the rigid body is spherical in nature, and a simple pendulum can be understood as a very special case of what you can say compound pendulum, or a special case of a physical pendulum where the mass is a point mass, radius tending to 0. So 2 pi root of L by G, the simple pendulum. So that is the case. Now if instead of the problem, if it is given as a hollow sphere, if it is instead of a solid sphere, if it is given as a hollow sphere, you should be a bit careful. The value of what do you say, the moment of inertia, it will be 2 by 3 mr square in place of 2 by 5 mr square. That you can take care of. And I think we can stop, or we can conclude this session by just giving you a conceptual question. You might have seen this conceptual question in some other examination. Try to find out the answer for this one. A pendulum consists of a hollow sphere. A pendulum consists of a hollow sphere filled with water suspended by a string. Water slowly leaking out. What happens to its time period? So this is a question that has appeared several times in many of the competitive examination, including your ordinary entrance examinations of +2 level. Maybe it will help you to you might be very familiar with this question, but try to find out the answer for this one. That's quite an interesting thing. Gives you a concept about the idea of center of mass or center of gravity. Okay, so we wind up this example here, and I'm giving you a homework that find out or discuss in general. Okay, discuss conical pendulum. You can just refer this one. You might have done it maybe in your undergraduate classes. Okay, anyway, just discuss the oscillations of a conical using Lagrangian equation. Use Lagrange's equation of motion and find out its time period. A conical pendulum. Refer to what is a conical pendulum. If you are not familiar, refer to it and see that you do this one. Okay, so it's also a very common system that we come across. Find out the equation for the time period and frequency of a conical pendulum. Refer to this one. Okay, thank you.